Welcome, not to ElixirConf, but also to ElixirConf and my talk here, which I have titled Roll Cages, Pit Stops, and Victory Laps, because I am going to use an excessive amount of car vocabulary just because I can. So my talk today is going to focus a lot on our launch at cars.com. We did a full-on rewrite of a very old system to Elixir, and I'm going to recap a little bit today of what happened on launch day, what was that like, and then I'm going to do a little bit of story time. So I'm going to tell some fun stories of some things that happened after we launched that we learned about, also some things that we did to kind of shoot ourselves in the foot, just as a heads up for any of you who might be working in LiveView right now. So without any further ado, let's jump right in. So before we get started and get into the meat of the talk today, just want to cover a little bit of the agenda for today. What are we going to talk about? Let's see here. So I'll start just real quick with a kind of a timeline of the project, like how did it come about, what were some of the motivations behind it, and then I will share the story of launch day. So we'll go from when we took the Band-Aid off and let all of our cars.com users come to the shiny brand new Elixir platform and kind of what happened after that. So after that, I'm going to jump into a couple stories. I'm going to tell a couple stories. The stories I'm calling pit stops. So the first pit stop that we're going to do is something I've titled The Mystery of the Sustained 100% CPU Utilization. This was a fun mystery that we learned about. Learned a lot from, and figured out that we needed to tune up our system so that this doesn't happen anymore. The second pit stop is, I'm calling it Elasticsearch Overload, but really this second story is about a very interesting interaction that we had with LiveView and on the back end, our Elasticsearch data store. All right, and then so we're going to wrap up with something I'm calling the winner's circle, because that sounds positive, and I want to end on a positive note. We'll talk about the road forward and kind of assess like how do I feel about where we are and how we landed with the project rewrite. All right, so I think a lot of you who have been programming for a while might think like, hey, cars.com, you've been around for a while, right? Didn't you have a bunch of stuff in production for maybe decades? Yes. And so, oh, this is fun. Sorry about the Finder thing. I learned one key takeaway from my talk today is do not give a talk on a company computer, because there is one client that really wants to be installed right now, and I can't. So sorry about that. So yeah, so why did we do a full-on rewrite, right? So it is kind of a complex question. There's a lot that went into it, but I'm just going to give a simple answer for today. Two simple answers. So number one is that the old system was really slow and hard to change, and changes were very brittle. So that was one big motivating factor. And then the other thing was the old system was costing us money, lots of money, through infrastructure costs, vendor contracts, and things like that. So we made the decision to just do the full-on rewrite. So let's jump in real quick. So the timeline of the project itself. It actually started, in a way, it started back in 2018, kind of laying the foundation for the project. The first commit was in January of 2019. So that's where we did the mix Phoenix new. And then almost 3 years ago to the day, we gave our first ElixirConf talk. This was a talk called 0 and 60 under 3 by one of our colleagues, Daniel Mackey, who's still with us at Cars, and Mike Binns from Dockyard, who is here somewhere at the conference. Flash forward a couple months, 2020 happened. So when the pandemic happened, cars, for the most part, went fully remote. So we were able to kind of expand our team and hire Elixir devs all over the US. Okay, so finally, 2 years, a little more than 2 years after that initial commit, we finally start revving up and getting this thing ready to put in front of real users. So what do I mean by revving up here? Let me close this Finder deal again. Sorry about that. Okay. So in April and May of 2021 last year, we started with a very, very small sliver of traffic. We would just pick off from the old cars.com, and we would direct them to the new Elixir experience. We bumped up a little bit from there. We went to 1% of production traffic starting to go to the new platform, and there's an asterisk there because we kind of did a little bit of our math wrong. That 1% was not really 1%. Like, it wasn't 100% of 1%, it was under 100% of 1%. This is actually gonna come back a little bit later. So just keep this context in mind as we walk through the next part of this. Okay, so we're going through these 3 months, right? April, May, and early June of 2021, last year. So during this whole time, time period, we have teams that are doing things like load testing. So we have some kind of targets, right? We want to be able to, when we release to 100% of traffic, we want to be able to hit certain latency targets and make sure that we just have the capacity that we need to be able to serve the existing cars.com traffic when we went live. So we would do a bunch of load tests. Based on the results of those, we would go in, loop back, and do some infrastructure tuning. So infrastructure tuning could be anything from, oh, maybe we need to upgrade our database size, go to a bigger instance of a database. Maybe we need to scale horizontally our web servers, and potentially even scale vertically some of our web servers. Okay, so the day comes, June 17th, 2021. This is the day where we decide we're just gonna rip off the Band-Aid and incrementally ramp up all of the traffic from the old cars.com and move it to the new cars.com. So that interesting footnote that I told you about earlier, where 1% wasn't 100% of 1%, when we got to 100%, it was actually 100% of 100%. So like more than 100% of what we were expecting. So that led to some interesting things. And let me close Finder again. There you go. Okay. So this is kind of where the story begins, right? So buckle up, because this is a cars talk, and oh, look, we're off to the races and everything's going really well, oh, this is unfortunate. It's time to call on-call engineering. Yeah, so we actually had a whole group of folks supporting the platform, obviously, when we went live. So what actually happened when we just opened up the floodgates? We had all of the users, all of the bot traffic, everything was now hitting our new Elixir platform. There are a couple things that we noticed looking through our APM tooling. So number one, latencies are higher than we anticipated, pretty much across the board. So it wasn't just a specific route or a specific page. It was pretty much across every route and every page. The other thing was our CPUs on our web servers were pinned at almost 100%. So what's happening? Like, what's going on here? It became pretty obvious at that point that we were under capacity. We didn't have enough capacity at the infrastructure level to serve the amount of traffic that we were getting. So a quick couple things that we could do about that. So number one is we could scale up our number of web servers. And for us, so we're, I think, a relatively vanilla Kubernetes deployment. We just scaled pretty much horizontally. So we added more containers or more pods. I think we actually tripled the number of containers or pods that were running that day. We also scaled up the production database. So we went from something that was maybe an intermediate or somewhat above intermediate level tier of Postgres to almost the top, or it might have been the top, like the biggest thing that you could get. We also scaled up Elasticsearch a little bit later on. So Elasticsearch is the data store that kind of powers the whole entire search experience for you at cars.com. There is an asterisk by this one because this happened later. It also did take the search experience down for a while that day, but this has nothing to do with Elixir. Side note, if you want to talk about a very obscure Alpine Linux thing with DNS records, let's talk after the talk here. OK, so at this point, right, so we've just done infrastructure tuning at this point. Some of these fires start to die down a little bit as we've added more capacity to our servers. And we start to see, in some sense, our latencies start to trend down. Our site is up and stable, which is pretty cool. This is a full-on rewrite of this really, really old system. The first day in production, our site's up, it's stable. Things aren't falling over. Things are not on fire. So I think we all kind of chalk that one up as a win. But we still notice that there's latencies that are still higher than we would like. So just a quick recap of launch day. So day one, we're a couple hours in. Like I mentioned earlier, we're running, we're stable. That's all great in a sense. We have a bunch of background processes that run just all day, 24/7, just ingesting data from a bunch of different sources. Those are super fast, they're efficient, those are running really well. So that's also really good. Bye-bye Finder icon. OK, so our search page. This is the big LiveView page for us. So our search page is it's rendered in LiveView from the router, and it's sitting in production, and it's handling millions of messages, which is pretty great, right? And also, we didn't need to modify any application code to reduce latency. It's just scaling infrastructure at this point. And it's been relatively quick or easy. So now I want to talk about racing and cars. So we're going to talk about roll cages. So is everyone familiar with a roll cage? Yeah? Like, you could be a really bad driver and flip your car, and it will protect you. So they're great. It's like a really good protection mechanism if you're a bad race car driver, like I probably would be. So did I say roll cage? Is really what I meant by roll cage. For us, in our sense at cars.com, the BEAM's preemptive CPU scheduling, I really like to think of as kind of a roll cage for us. Like, it has protected us against taking our entire site down. So how does that work? To briefly high-level talk about how this protects us, in a sense, we'll have to get in a little bit to two different execution models of how you can schedule work to be run on your CPUs. So with a BEAM, we get preemptive scheduling out of the box. There's another execution model called cooperative scheduling. And cooperative scheduling is like a very, basically the scheduler in cooperative scheduling is like a teacher who's a big pushover because he needs cooperation, or he or she needs cooperation from a task to yield time on the CPU to other tasks that are waiting in line. So the cooperative scheduler might say, hey, you busy task over there, can you let the other person behind you run on the CPU? And the busy task might be like, yeah, no, I'm good. No, thank you. The preemptive scheduler, his model is he's much more strict, right? So he'll look at the busy task and he'll say, OK, you're done. You've had enough time. Get out of here. So the busy task will go back to the back of the line. It's actually a lot more complex than this, but at a high level, you can kind of think of preemptive scheduling this way. So what does that actually mean for us, though, right? As engineers that are supporting an application in production. So for one thing, this gives us more time to react. So if we have bottlenecks, CPU bottlenecks, processes that are CPU intensive somewhere, we have more time to react to that because the site is not completely ground to a halt because we're still getting time on the CPU for other tasks. So non-CPU bound tasks, like let's say a web request that doesn't really do much, it's not going to get completely blocked and shut out just because it has a CPU intensive task running in a queue in front of it. And to a certain extent, this also let teams operate when there's issues with CPU pressure and things like that. You can operate in an environment where you're not worried about a full-blown site outage, right? And I think this has helped us in a number of cases. So, okay, so we're a couple hours in now. I think everything's cool, great success. Let's get into story time here. So the next two stories are going to be a little bit about how we ended up shooting ourselves in the foot in a couple ways, and we'll talk about how you can avoid that. All right, so we're in production. We noticed that our web server CPU usage is just trending up, and then we'll end up sitting almost at 100%. So that's bad, right? That is bad, as a matter of fact. It turns out that that is bad, Jason. But the real bad news here is that when we go to look at what's happening and get more details about what's happening with the CPUs, one big thing that pops out to us is there's 25 million process crashes. This is in a couple hours, right? That's a lot of logs, first of all, and that's also a lot of process crashes. The majority of those are LiveView processes that are crashing. But on the bright side, you can still go to the site and shop for your favorite car. There was plenty of Jeep Wranglers that day. I remember from looking at them. The site was still usable for the most part, but our logs were saying something really, really strange is going on. What is happening? So to get into that, let's get into a little bit of a detour of how we got in this state to begin with. So flashback to before we go to our production launch. We have a lot of product folks who are testing things in our staging environments. One thing to note, just keep this context in mind. In our staging environments, we're deploying code almost nonstop at this stage. So people were noticing that you were getting constant refreshes on some of our pages, especially some of our LiveView pages. So why is this happening? This was deemed an issue because it kind of affected the way that we were counting analytics. So a little bit of extra context here. For those of you who don't know, LiveView actually itself, the client-side LiveView code, it might force a full page reload for you in certain states. So some unrecoverable states that it can find itself in. For example, if your LiveView fails to mount continuously, one thing that LiveView might do to try to fix that will be to do a page refresh. And the reason it does that is because the client-side code, like HTML and JavaScript assets that have been loaded on the client's browser, might be out of sync with the LiveView processes that are running on the server. So a page reload can get you out of that state. It can get the client and the server back in a good state. A lot of our issue was actually, it was heavily deployment related. A couple things that we didn't really anticipate or think about was that at cars, we get a lot of users who will pull up 10 or 11 browser tabs of different searches and just leave them idle. And a lot of these were LiveView connections. So for each tab that you have open, you have one LiveView socket connection to one of our servers. And then when we do deployments, we didn't really think about this all that much until it really hit us in the face. When we do deployments, we do rolling deployments. So your socket connection is going to get disconnected from your server. It's going to bounce around to another server that can handle it. And the other thing to keep in mind here is that some of these deployments, when we're releasing new code, they might contain some changes to the LiveView modules that we have on the servers. So just a quick diagram of that, right? So if you're a user, you've got your socket connection, that's to a server. When a deploy goes out, you might bounce around because we're going to take one server down, bring another new server up, and this new server might have brand new LiveView code that maybe is not really in sync or ready to handle the old LiveView client-side code that you had. So, okay, now we have a decision to make. There's a few things that we could do here to fix this. One of the things we could do is patch it, as in patch LiveView's page refresh thing. What if we just never let LiveView reload the page at all? So that's one thing that you could do. But if you do that, what happens to those unrecoverable states? Yes. So this is actually the route that we went. We patched LiveView so that it would never reload. That means that when we got into a bad state, something like this would happen. So we would deploy some code. So now we would have a LiveView process that was out of sync with old client-side messages. And at this time, we actually had, this was an old version of LiveView too, but we had a bunch of stateful components that would receive messages right after a mount. So in a good state, this might be a little bit difficult to see, but in this state, what's happening is we would have our client send up to our LiveView process a message saying, hey, server, send this message that I've given you to the stateful component with ID of 1. And if we're in a good state, client and server are in sync, the LiveView process will say, OK, stateful component number 1, handle this message. It'll give you a response back, and then everybody's happy. But if we made a change, like if we added a new stateful component in this time, and the order those things got out of order, the client would still send up that same message, and the LiveView process would then say, OK, I'm going to send this to the stateful component that I think is number 1. And then it will go over to that component, but that component is going to say, I don't know what to do with this message. So you end up calling handle event, the callback handle event, on the wrong stateful component. And this leads to tons and tons and tons and tons and millions, actually, of function clause errors. And it's a complete wipeout. So this is what happened to us that day. So the mechanics of the crash loop here was our LiveView process would crash because we would get the function clause error. So the process exits. But because these are supervised processes, the supervisor would say, hey, try that thing again. And then that just happens forever and ever and ever and ever until you fix it. So it looks something like this, I imagine. Just keep crashing into the same car every single time. But this was for like maybe tens of thousands or hundreds of thousands of browser tabs that we had open. OK, so now an emergency pit stop ensues, right? We have to do something about this. What do? We do two things. There's a short-term fix. There's a long-term fix. The short-term fix is to sweep everything under the rug. And what I mean by this is, since these are stateful components, they didn't know how to handle event messages. Essentially, what we did was we just wrote handle event functions on every single stateful component and just no opt, right? We just did no reply socket. And that was largely OK. But we also had some longer-term fixes there. So longer-term fixes, we needed better monitoring on these LiveView states so that we could detect this if it ever happens again, right? We want to know about it immediately. We also got a task force together to fix known errors that would actually cause those processes to crash, because we didn't want that to happen anymore. And then we also had to solve for, at least talk through some of the issues through deployments. So this is one of my favorite graphs here. This was right around our launch time. And it shows our latencies. So median latencies all the way up to P95 latencies across the site. So you can see that our P95s were pretty high. They were like 3 seconds, which was way above what we wanted. And then when we did the quick short-term fix, the continuous crashing of those LiveView processes was basically what was eating up our CPU and causing latencies to spike up. As soon as we push that code out, then the latencies come way back down. And now we're around our performance targets. Under a second for P95, which is great. OK, so now we're really happy. We're moving along. Everything's great. Quick takeaways. These might be obvious, but be careful when you're patching code. And when you do, make sure that you understand why it did what it was doing and why what you're doing might make it worse. OK, so quick foray into our second pit stop here. So this one, I'm calling it Elasticsearch overload, but it's actually a kind of funny interplay between our LiveView page, our search page, and then the backend Elasticsearch data store that we use to really execute your searches. All right, so again, in this story, deployments are going to play a front and center role. And what we notice here is around deployments, specifically in deployment windows. As a deploy is running, we start getting flooded with alerts from Elasticsearch. And so here's a crazy looking graph that you don't really need to know too much about, but you can see these two mountains of red things at the very end of it. Those are bad. Those are bad, and those are both happening during deployments. So what we see here is when this thing goes over 1,000, that means Elasticsearch is going to be load shedding, which means that if you're trying to search, Elasticsearch is going to be like, yeah, no, I'm not going to do that for you. So that's not great for us. So what's going on? What's happening with this whole deployment and Elasticsearch flood of requests that we're seeing? So another little detour. Let's break down a cars.com search request. If you go to our search page, you'll see that there's a bunch of forms. So it's forms pretty much all the way down. We have forms for filters, sort options, pagination, things like that on the page. And just to prove that point, I took a screenshot. There's forms that you can see there. So let's diagram that out a little bit. So when you update any one of those forms, when you change any one of those forms, let's say you want to like change your search to look for fancy cars. That's not a model of a car. Yeah, BMWs, whatever. That change is going to do a client-side navigation for you. That's going to send a message to LiveView. We're going to handle a bunch of stuff and handle params in LiveView. And eventually, we're going to turn that into something that can be run as a search against our backend Elasticsearch data store. So just keep that in mind. You could change any one of those forms. It's going to end up resulting in an Elasticsearch query. There was a couple things that we missed about those forms, though. So number one is, well, they're all rendered and controlled by LiveView. Number two, there's this feature called Phoenix Auto Recovery in LiveView. So how many of you are familiar with this auto recovery thing? OK, so there's a few of us here. We kind of missed this. This is straight from the docs in LiveView. It's straight from the guides. And it might not really click when you read it at first. What it does is, let me just read this here for you. By default, all forms marked with Phoenix change will recover input values automatically after the user has reconnected on the or the LiveView has remounted after a crash. This is achieved by the client triggering the same Phoenix change to the server as soon as the mount has been completed. So that's a lot of theory. Let's think about how that actually plays out in real life. It turns out that this default behavior is usually what you want a lot of the times. So let's say we have a form, like we're creating an account, and we're storing on the LiveView process or the LiveView server state. We're storing your name, last name, and email. But if you think about, so what happens when a deploy goes out or a socket disconnects, reconnects, and you've lost your name, first name, last name, and email in memory there. If the user tries to hit submit, their form says that they filled everything out. Your LiveView state says that I don't know anything about this person, right? So what the auto recovery will do is as soon as your socket reconnects, it's going to shoot up a change event so that you could repopulate that state right off the bat. So that's good. And this is, I think, a sensible behavior in most cases. But what if you don't actually need that state on the server? So for our case, we have a lot of the state that we need in the query params from the user's browser. The other thing to think about is what if that on change has other side effects? Like what if you're making an expensive API call or something like that when you get an on change event? I'm glad you asked because we actually did have, as I mentioned, a different solution for form state. That's all captured as query params in the browser. And our side effect was every time you made a change, it resulted in an Elasticsearch query, right? So a change of a form resulted in a corresponding Elasticsearch query. So some fun facts. We had 6 forms on the page. And every time they changed, they would make an Elasticsearch query. So all were controlled by LiveView, all had the default auto recovery behavior. And when a deploy went out, a lot of our users would just be looking at their search results that they asked for, and then their socket would disconnect, it would reconnect, and on reconnect, all 6 forms would be like, here's all the information that you already know about the search that I want. And so the server would execute 6 of the same exact search requests for a single user on a single page, all in a very short span of time. So if you think about what happens in a deployment, as socket connections are bouncing around, And maybe we have a user that has 10 pages open, right? So when a deploy goes out, now they have, in a very short period of time, they're going to be issuing 60 of the same exact Elasticsearch requests in a very short period of time. Now multiply that by tens of thousands of users, and then, whoopsies, that's not good. So we had something like 250,000 requests would go out during a deploy to Elasticsearch, where generally our baseline would be something along the lines of maybe 30,000 or so per the same time period. So the fix here, the great thing about this was fix is super easy. It's just to add Phoenix auto recover ignore to all the forms, which is exactly what we wanted here. We didn't need that behavior. It was better just to ignore it. And that's it. So quick takeaways. Read the docs well, and then understand the options and trade-offs that you have available. So for us here too, I mean, the LiveView guides, if you read the guides, those are really good, right? Like they will teach you a lot of different things, and then if you could put them into practice on the code that you're working on and think about how it might affect your infrastructure downstream. Super important to do. Just make sure that you have a practice of it, because it can save you a lot of time and headaches down the road. And Elasticsearch lived kind of happily ever after, and everything is great. So, all right, so I just gave you two kind of stories where I talked about some difficulties that we had, but I think overall, right, we've been in production now for over a year in Elixir. And I would say, and I think a lot of our colleagues would agree, that we are still a resounding Elixir success story. So some key takeaways for us. So within a couple of years, we did the full replatforming and launch. Check that off. We have LiveView handling hundreds of millions of messages daily. And we've actually had days where we had billions of LiveView messages being handled. So if you're curious about how well LiveView can scale in terms of message processing and throughput, I think the answer is pretty well. We have tens of millions of ingestion messages, background jobs running per day. Those are a lot more efficient, a lot faster now than they used to be in our older system. But did we meet our goals? So we ship daily. This is good because on our old system it would take sometimes weeks to get a change out the door. Now we're shipping and changing things daily. Our system's also costing us a whole lot less money. And I think we also had some tangentially related wins too by moving over to Elixir. So visibility into our running platform is really, really great with the improvement and just the overall community awareness of telemetry, adding that to new libraries and things like that. We've been able to hook into that and just really, in a very short period of time, be able to build out nice dashboards, alerting, monitoring, really nice ways to look into our running system, and basically, in a single glance, be able to tell how healthy the system is. So the other thing that was kind of a tangentially related win for us is SEO is really important. With LiveView, server-side rendering is you get it for free, which is really cool, and you still get interactive client-side code pretty easily out of the box. And I think another thing for us is that we have a big umbrella project. All of our developers have access to the same code, the same repos now, whereas before we were more fragmented. So some engineers would only know that their one microservice maybe that they were working on and need extra tools and setup to get running with the full entire suite of tools that they needed to actually power cars.com. So can your team learn anything from us? I think this is kind of a theme that I've noticed in a lot of talks today. You don't need a full team of Elixir and BEAM wizards to get started. A lot of us at Cars are from different programming language backgrounds. A few of us are from non-programming backgrounds as well. But I think even with that, we're doing pretty well in production. So again, as I mentioned earlier, the BEAM's preemptive CPU scheduling can save you in a lot of cases where in other systems you might actually be in trouble. I mentioned this earlier, but telemetry, related projects, and telemetry being embedded into almost all the libraries now gives you really good observability story when you're using Elixir or Erlang or other BEAM languages. And documentation, I think, is first class. which is really good, right? So hex docs, the guides, as I mentioned, are a really good resource to get started. So that's it. And that's a wrap. The one on the right for me is a wrap. Or a burrito, I don't know. But that's all. Thank you so much for coming to my talk.